I am Manas and I will be teaching you physics for 11th and 12th standards. So let's begin with our first topic, force and its types. Now, what is force? Force is that quantity which is required to push, pull, carry, throw, deform or break any object. Force leads to change in velocity, position or shape of the object. So, when we see a push or a pull or a carry or throw or deform or break of object, we can say that force is applied. And this force causes a change in velocity or position or shape of the object. So, let's see them one by one. Here in the first case, a boy is pushing a box and this has caused the change in velocity of the box. So, we can say a force is applied on the box. Now, here in the case of pull, a boy is pulling a box and this has caused the change in velocity of the box again, and we can say that force is applied on the box. Now, in case of carry, a boy is carrying a box and this has led to change in position of the box from S0 to S1. So, again we can say that the force is applied here. In case of throw, here a boy is throwing a ball to the basket and this has caused a change in velocity as well as change in position of the ball, and we can say that the force is applied on the ball. Now, in the case of deform, a squash ball is hit hard on the wall and this has caused a change in shape of the object. So, we can say the force is applied here too. And here in case of the break, a bulb fell on the ground and it broke. So, there is a change in shape of the bulb. So, we can say that a force is applied here too. So, we can say a force is applied on the object when it fulfills any one of the criteria or more than one of the criteria from this point: push, pull, carry, throw, deform or break, and it has led to the certain changes from any of this one or more than one changes from the second point, the change in velocity, position or shape of the object. Are you clear? So, let's move to our next slide. Now, what are different types of forces? So, force can be broadly classified as fundamental forces and as derived forces. Now, what are fundamental forces? Fundamental forces are the basic forces, they exist necessarily. So, the fundamental forces were there from the existence of the earth itself. And what are derived forces? Derived forces were derived from fundamental forces. So, they were later on derived by human beings. So, there are four kinds of force which falls under fundamental forces. They are: number 1, gravitational force; number 2, electromagnetic force; number 3, strong nuclear force; and number 4, weak nuclear force. And under derived forces, there are many more forces apart from these three which were derived by human. So, some of them are elastic forces, spring force, friction and some other force. Are you clear? Now, we will discuss all these fundamental forces one by one. So, let's move to our next slide. So, first is gravitational force. Now, what is gravitational force? Force of mutual attraction between any two objects by virtue of their masses is called as gravitational force. Here we can see a diagram. M1 and M2 are two bodies. Sorry, these are the two bodies with masses M1 and M2, and they are separated by a distance d. And gravitational force is directly proportional to the masses of the bodies. So, if the greater the masses of the bodies, greater will be the gravitational force. and the gravitational force depends on the distance of the two bodies but inversely. So greater will be the distance between the bodies, lesser will be the gravitational force. Fg is inversely proportional to 1 by d square. Gravitational force requires no medium to act. So there might not be any medium, and gravitational force exists in vacuum too. Gravitational force is the weakest of all the fundamental forces. So there are four fundamental forces, and amongst the four fundamental forces, gravitational force is the weakest. Gravitational force is the universal force. So it is always present between any two bodies. They might be on Earth or they might be outside Earth. Some examples of gravitational force are motion of moon and artificial satellites around the Earth, planetary motion, motion of the falling bodies. These are certain examples of gravitational force, right? Now let's move to our next slide. Few basic concepts about gravitational force. So gravitational force is given by Fg is equal to G m1 m2 m1 and m2 are the masses of the two bodies by d square. D is the distance between the two bodies, and G is the gravitational constant which is required to equate gravitational force, and it is given by 6.67 into 10 to the power minus 11 Newton meter per kg square. We'll learn about gravitational force in details later on. Now see, two rigid bodies on top of the table doesn't move towards each other, but gravitational force is still acting between them. So why is it so? Why don't they move towards each other? Because the masses of the two bodies are very small for the gravitational force to cause them to move towards each other. So they don't move towards each other even though gravitational force is acting between them. Now next, let's see a next case. Apple falls on the ground but moon doesn't. So why is that an apple from tree falls on the ground but moon doesn't, and it continues to revolve around the earth? This is because of the distance. Gravitational force acts both on the apple and the moon, but the distance between the apple and the ground is very small compared to the distance between the moon and the earth. So gravitational force in the case of the apple is very strong. That's why apple gets attracted towards the ground and falls on the ground, while the moon, although it is attracted by gravitational force, it still continues to rotate around the earth and doesn't fall on the earth. Is it clear? Now let's move to our second fundamental force, that is the electromagnetic force. So what is electromagnetic force? Electromagnetic force is in fact a combination of electric force as well as magnetic force. Now what is electric force? Study will see what is electric force now. A charge q naught, let q naught be any charge. A charge q naught at rest will produce an electric field E. Okay, and this electric field will exert a force on other charges in the vicinity. So the electric field will exert a force on the other charge nearby it. Then that force may be attractive if the charges are unlike, that is, in case of negative and positive charges, that there will be an attractive force, and the force may be repulsive if the charges are like charges. In case of positive and negative charges, the force will be negative. Here we can see two charges, one is positive, one is negative. The electric force gets stronger as charges move towards each other. You can see here, and gets weaker as they move apart. The electric force again gets stronger as the charges get larger, but both the charges always feel the same force, right? Next is magnetic force. What is magnetic force? Now any moving charge will produce a magnetic field around it. See, a charge is moving here in this second case. Yeah, charge is moving, and there you can see a small green circle over here. That is the magnetic field produced by the moving charge, and this magnetic field will exert a force on the moving charge also, and that is the magnetic force, and that can also be attractive or repulsive. So what we see here, the electric and magnetic effects on charge are inseparable. So the electric and magnetic field will always act together, they cannot be separated, and together they are known as electromagnetic force. And this electromagnetic force acts over a long distance and doesn't need any medium to act. So the distance on which the electromagnetic force will act can be very large. And electromagnetic force is much stronger than the gravitational force. And unlike gravitational force, as we have already seen here, the electromagnetic force can be attractive or repulsive, whereas the gravitational force is always attractive. The electromagnetic force dominates all phenomena at atomic and molecular scales. That is, it governs the structure of atoms and molecules, the dynamics of chemical reactions, and the mechanical, thermal, and other properties of the material. So atoms, we know, are the building blocks of matter which bind together to form molecules, right? And electromagnetic force acts in an atomic level to keep the structure of the atom intact so that it doesn't break out. Okay, are you clear? Now let's move to our next slide. Some discussion on electromagnetic force. So electromagnetic force acts inside atom between the negatively charged electrons and positively charged protons. So here in the diagram we can see that the red color are the protons and blue color are neutrons and yellow color are the electrons. The electrons are revolving in its individual orbits, and the structure of the atom is kept intact because of the electromagnetic force acting within the atom. The attractive force between proton and electron, repulsive force between electron and electron, balances each other and keeps the structure of the atom intact. Right? Now the second point, tension and normal reaction, which balances gravitational force, are in fact electromagnetic force. See, here we can see a pulley system, and here we can see a boy carrying a box. In both the cases, the force of gravity, that is gravitational force, pulls the mass towards the ground. That is, they are acting downwards, they are pulling the mass towards the ground. This and this are gravitational force acting towards the ground, and there should be some greater force that prevents them from falling on the ground, because otherwise they would have the rope here, which is onto which the mass is tied, would collapse, and the hand of the boy here would have collapsed and the box would have fallen on the ground. But it is not so. Some force is acting opposite to gravitational force, and this force is the electromagnetic force. The normal reaction here and tension here are in fact the electromagnetic force, which is acting upwards opposite to the gravitational force. This happens because the charge or atoms at the surface of contact between the hand and the box, have some atoms, right? Because this is also matter and this box is also built of matter, and these atoms interact with each other. Here also there will be interaction between the atoms of the rope and the surface of the pulley, and this will produce an electromagnetic force of very high magnitude, which is much higher than the gravitational force, and which will prevent these masses from falling to the ground, right? So I think you are clear till this topic. Now let's move to the next topic, the third fundamental force, that is the strong nuclear force. Now the strong nuclear force operates within the nucleus between proton and a neutron. You can see in the diagram, these are red color the proton and white color the neutron, and the strong nuclear force is acting between the proton and the neutron. It is charge independent and acts equally between a proton and a neutron and a neutron and a proton and a neutron. So the magnitude of force acting between two protons and the magnitude of the force acting between two neutrons and a magnitude of the force acting between a proton and a neutron will always be the same. Without this attractive force, the nucleus will be unstable due to electric repulsion between protons. As we already know that like charges always repel each other. So if there were no electromagnetic, no strong nuclear force, then the proton would have repelled and the nucleus of the atom would have broken. But we never see that, and we always see that the nucleus of the atom is always kept intact, and this is due to strong nuclear force. The strong nuclear force is extremely small, of about nuclear dimension 10 to the power minus 15 meter, and responsible for the stability of the nucleus, and it is the strongest force. So strong nuclear force acts within a very small or very minute radius, that is 10 to the power minus 15 meter, and it is the strongest force of the all fundamental forces. The strong nuclear force, as the name strong suggests, is the strongest of all the fundamental forces, right? Now a small question: force acting between proton and neutron inside the nucleus is not gravitational force. Why? So we may, it may come to your mind that this might be the gravitational force acting between proton and neutron, which keeps the nucleus intact, but that is not the case, because protons and neutrons are minute in sizes, and as the gravitational force is directly proportional to the masses of the bodies on which it acts upon, gravitational force can't be strong enough inside the nucleus. So as the masses of protons and neutrons are very small, this is not the gravitational force that is strong enough to keep the nucleus intact, right? So this is not gravitational force, and this is some other force which we know as strong nuclear force. Okay, is it clear? Next, move to our next slide. The fourth and the final fundamental force is the weak nuclear force. The weak nuclear force appears during radioactive beta decay of nucleus in case of heavy metals. So some heavy metals are uranium, plutonium, and in case of radioactive reaction of these metals, weak nuclear force appears. In beta decay, the nucleus emits an electron and an uncharged particle called neutrino. So what happens is, in case of radioactive beta decay, the nucleus emits one electron and one neutrino, which is an uncharged particle, right? The weak nuclear force is not as weak as gravitational force, but much weaker than the strong nuclear and electromagnetic force. So weak nuclear force is stronger than the gravitational force, but weaker than strong nuclear force and electromagnetic force. The range of weak nuclear force is exceedingly small, in order of 10 to the power minus 16. So the weak nuclear force acts within a very small distance of 10 to the power minus 16 meter, right? Is it clear to you? Now let's summarize all the four fundamental forces and compare them with each other. First is the range. The range of gravitational force is very large. It's a long range force, and its operating distance is infinite. The range of electromagnetic force is also infinite, and it's a long range force. Short nuclear force, on other hand, is a short range force and has an operating distance of nuclear size, that is 10 to the power minus 15 meter. Weak nuclear force is also a short range force and has a range shorter than the strong nuclear force, that is 10 to the power minus 16 meter. Next is nature. By nature, gravitational force is always attractive and it's charge independent. And electromagnetic force, on other hand, may be attractive or repulsive, and it's charge dependent. Strong nuclear force is also attractive and charge independent, and the nature of weak nuclear force can't be said because it occurs during the electromagnetic radiation within the nucleus. Now, gravitational force operates among all the objects in nature, and electromagnetic force operates among the charged particles in the nature. And strong nuclear force, however, operates within the atom between nucleons and the heavier elementary particles, that is electrons. Protons and neutrons are together known as nucleons. And weak nuclear force operates among some elementary particles, particularly electron and neutrino within the atom, right? So are you clear? Thank you, students. Hope to see you again.